Hello all, this is Christopher Dana from Trinity Software. Welcome back to part 2 of our student mental health analysis series. In this video, we will dive into bivariate analysis using Python and SQL to uncover deeper patterns in the data. If you haven't watched part 1 where I have covered univariate analysis, check that out first. Link is given in the description. So this is the dataset which you are using for our analysis. Make sure you are importing the required packages and you have connected to the SQLite database and you have written the data frame to an SQL table. Okay, now we will move on to the bivariate analysis. So bivariate analysis means analysis of two variables together to find relationships. The purpose is to explore how one factor affects another. Bivariate analysis can be categorized by the types of variables. The first category is categorical variable versus categorical variable. Second, continuous versus continuous variable. And third one is categorical versus continuous variable. Okay, we'll see examples for each and every one of this category. Let us take the first example, anxiety by gender. So this is our data set. Gender contains two values, male and female, and anxiety is a scale which contains value from 1 to 5. Okay, so this is actually the association between continuous and categorical. Since gender is the categorical variable and anxiety is continuous variable. Okay, now let's write the SQL query for this bivariate analysis of anxiety by gender. Q equal to select gender anxiety and the number of students. Name it as total, count of star as total. From the table name is students and we are grouping by gender, then anxiety. Okay, this data frame ANX underscore DF can be obtained using pd dot read underscore SQL underscore query. Two arguments, the first one is a query and second one is a connection which we have established. Okay, execute it. We got the data frame, gender, anxiety and the total number of students. The anxiety level 1 means no or mild anxiety and 5 means severe anxiety. Okay, so now we can visually represent this in the form of a bar chart. Use Seaborn's catplot method, sns.catplot, data equal to data frame which you have just created, anxiety underscore data frame, and x value is gender, y value is total count. It is stored in the variable total. And to represent anxiety, you can use hue parameter. Hue equal to anxiety. This hue parameter is used to introduce an additional variable to the plot. Okay, then select a palette. Let me use dark palette and kind of the plot is bar. Okay, let's name this plot plot.title anxiety by gender, plot.show. So we got this visual representation. A bar chart is obtained. Y-axis contains the total number of students. X-axis contains the male and female and the bar represents the anxiety level. So here we can visually compare how anxiety levels differ between male and female students. There is higher anxiety among male students. So male students consistently report higher counts across all anxiety levels compared to females, especially in 3 and 4. Moderate to severe levels, male students have a much larger representation. Female students appear fewer in number overall, but they show a higher proportion in the severe category. Okay. Now let us see another example, bivariate analysis of average anxiety by social relationship. This also comes under continuous versus categorical. Here, categorical variable is social relationships. It can take value from 1 to 5. If the value is 1, it means poor social relationships. If the value is 5, it means excellent social relationship. So that is independent, and dependent variable is anxiety, continuous variable. Okay, so let's copy this query and we can make the changes. So this is social relationship anxiety. We need to select social underscore relationships. Then we need to find out the average of anxiety. We can round it to 2 digits. So use round function average of anxiety, comma 2. Count star as total from students. Here we are not going to group anxiety since we are finding out the average. So we are going to group by social relationships and also order by social relationships. Fine, let's check this data frame. We can rename this. Round of average of anxiety can be renamed as average underscore anxiety. Okay, social relationships from poor to excellent and average anxiety. From this itself we can infer that when the poor social relationship is there, the average anxiety is more. So we can draw a bar plot for this. Plot dot figure size equal to 10,6. Draw the bar plot. Let me store it in a variable. SNS dot bar plot. Data equal to data frame name is SO underscore ANX underscore DF. And X is social relationships. Y is average underscore anxiety. You can give a palette. Let me use this. Fine. Now add this total student counts labels in the bar itself. Okay. For I represents the index of the current row and row is the current row value in so underscore anx underscore df dot method iter rows. Okay. Ax dot text. The first argument is I. Then row dot the average anxiety plus 0.05 is padding adjustment to improve the readability. And then we need to write student count is stored in the variable total. Convert that into string and row dot total. In what color you want it to be written. The horizontal alignment, you can make it as center. Now we can fix the title, plot dot title, average anxiety by social relationships. And we can give the X label, plot dot X label is social relationships. Then we can also give plot dot Y label, average anxiety. Now we can check the plot. So the name changed, okay. We got the average anxiety by social relationships. Let me make it as 10,5 to see the output clearly. Here, the social relationships in x-axis and the count of the students is represented in the bar itself. Okay, higher social relationships tend to relate with lower average anxiety. Social relationship 4, it is the lowest, and there is a slight rise at 5. Even though they have excellent relationships, anxiety increases slightly compared to the level 4. So this could suggest that while very strong social relationships help, other pressures like academic pressure, financial stress still will influence the anxiety. Okay. Now we will move on to the next category of bivariate analysis, that is association between two categorical variables. We are going to perform a bivariate analysis of CGPA and depression. Both are categorical variables in this case. So let me write the query. CGPA df, select CGPA and depression from the dataset. CGPA is a categorical variable and depression ranging from 1 to 5. It is taken as categorical variable here. Okay, so change it as CGPA and depression. Find the count of star as total from students, and we are going to group by CGPA and depression. Okay, so let's check the output for now. We are grouped by CGPA and depression. So we can get a visualization by using heat map crossstep visualization tool. This tool is to display the relationship between two categorical variables. Let's create a crosstab first. CT equal to. In the pandas, we have this crosstab method. Here we can directly use the original data frames value itself. df of CGPA is the first argument. df of depression is the second argument. And we have one more parameter called normalize. By default, it will be false. Here we are setting it to index so that we can express each value as a percentage of its respective row total. Okay, now plot heat map. SNS dot heat map. The first argument is the cross tab itself, and if you want to mention that values which you have calculated, annotation is set to true. C map is the colors used, any colors, greens, and FMT is the formatting of annotations. If you just want two numbers after the decimal point, you can use point to F. Now let's give a title, depression by CGPA, and plot.y label CGPA, and plot.x label is depression level. You will see the plot heat map cross tab. So we got it in the shades of green. Since we have given normalize equal to index, the value is the percentage of its respective row total. Okay, all the row total will be 1. Y value is CGPA, X value is depression level. Students with low CGPA 0.0, 1.5 to 2.0 are more likely to show higher depression levels. Okay, students with mid-range CGPA, that is 2 to 3. More number of students, you can see the darker green color. Here it is 0.5, 0.32. Okay, so students with mid-range CGPA cluster more around moderate depression level, that is level 3. And if you consider CGPA 3 to 4, the students with high CGPA show mixed depression levels, which suggests that academic success doesn't fully protect against mental health struggles. So this heat map suggests a non-linear relationship. Poor CGPA clearly aligns with high depression, but excellent CGPA does not guarantee low depression. There can be other factors to still affect high performers. Okay. The next category of bivariate analysis is association between two continuous variables. We can take the example of depression by age. So depression score can be considered as a continuous variable here, and age is a continuous variable starting from 17 till 26. Here we are not going to write the SQL query. To find out the association between two continuous variables, we can check the correlation. We can also plot, scatter plot, and regression. So scatter plot is to plot the relationship between two variables. Okay, plot dot figure fixed size equal to 8,6. Now the scatter plot from Cbon. Data is the original data frame DF. X value is age. Y is equal to depression. And you can color, the dot representation color is equal to blue, and S equal to 80. It controls the size of the marker, that is the dot size. Okay, they will execute it. Y-axis is depression and x-axis is age. Each dot is a value in the dataset. Okay, see in detail after drawing the regression trend line. Regression trend line is actually the line of best fit drawn on the scatter plot to visually represent the trend or relationship between two variables. Okay, so you can use SNS dot regression plot. Data is equal to DF, X equal to age, Y is depression. Here scatter is set to false. It means that plot only the regression line without the scatter points. Color of the regression line, you can give red, and then confidence interval, we are setting it to none. By default confidence interval will be present. Here we are not giving the confidence interval. Okay, we can give the title, plot dot title, depression by age, plot dot show. So we got the regression line here. We can see that depression scores from 1 to 5 are spread across all ages. And make it as 5, 8,5. Students of different ages report a wide variety of depression levels. And if you see the regression line, it is slight upward trend. It means as age increases, average depression score tends to increase a little. And the slope is shallow, so the effect is not very strong. Okay. At each age, students report both low and high depression scores. So it means that age alone is not a strong predictor of depression. If you see younger students from 17 to 19 show a mix of low and high depression scores, and the older students slightly higher tendency towards higher depression. So it is actually a weak positive association between age and depression. Okay, we can check this statistically, that is, check the correlation between age and depression. We have functions for checking the correlation in Python to confirm whether the upward trend is significant or not. So from scipy.stats, we can import Pearson R, find out correlation and p-value using Pearson R method, df of age as well as df of depression. We can print both the correlation as CORR and p-value is p. So we got the correlation as 0.089 and p-value is 0.40. Correlation is very close to 0.08. Means almost no linear relationship between age and depression scores. So p-value, if it is greater than 0.05, it means that it is not statistically significant. So there is no significant association between students' age and depression levels in our dataset. So depression scores appear to be independent of age. Okay, now we can perform the regression plot and correlation for two other continuous variables, that is isolation and anxiety. Isolation contains the values from 1 to 5, anxiety values from 1 to 5. Both are considered as continuous variables. Let's draw the regression plot. In the regression plot itself, you can use the scatter plot. That is snx.regression plot. Data is equal to df. X value we are going to take isolation and y value is anxiety. Here scatter keywords equal to, give a dictionary alpha colon 0.5 and we can give regression line keywords equal to color colon red. Confidence interval, let it be present here. Okay, scatter keyword we have set alpha as 0.5. It means that we are setting the transparency of the scatter points to 50%. Regression line color is set to red. Okay, we can give the title isolation versus anxiety, give plot dot show. We got this. X-axis contains isolation, values from 1 to 5. Each dot is one student's score. Red line is the regression line. So this is a positive trend. The regression line slopes upward, confirming a positive association. And at each isolation level, students report a range of anxiety scores from 1 to 5. And we have an interesting factor here called confidence interval. That is this pink shaded region. So the shaded band shows the uncertainty around the regression line. Since the band is relatively narrow, relationship is fairly stable. So students who feel more isolated tend to have higher anxiety levels. Okay, so we can confirm this by finding out the correlation. Here we can find out CORR correlation equal to df of isolation dot CORR df of anxiety. And the method used here is Pearson method, which is the default method. Let's check the value of correlation here. So it is 0.67. It indicates a moderately strong positive correlation. Since the value is positive, it means that isolation increases, anxiety also increases. Okay, so that's it with part 2 of mental health analysis. We covered how to uncover patterns using bivariate analysis techniques. In the next video, we will see multivariate analysis. Thanks for watching. If you like this video, kindly share and subscribe.